Good morning, everybody. We're going to continue looking at looking at quadratics, and today we're going to focus specifically on finding the equation of a quadratic from its graph. So whenever we're given enough information about a graph, we can determine what the equation is by using some mathematics, substituting in some points to the forms that we know. So what we're going to look at first is we're going to start by writing equations for these two parabolas. So the two ways that we have looked at to do that, we've got standard form here, which is ax squared plus bx plus c. And then we also have looked at factored form, which is just a times x minus the x-intercept times x minus the x-intercept. And so those are going to be the two main ways that we go and do this. So whenever you're asked to write an equation for a quadratic, so on example 15, this is on page 149 in your orange book, we've got this perfectly drawn parabola. I'm sure it's totally to scale. And so it's important to understand what you're given from this picture. It's important for you to understand, okay, what can I use to help me write an equation? So here I've got x-intercepts. So I've got x-intercepts of -1 and 3. And I've got a y-intercept here of 3. So if you're given the x-intercepts and you're given the y-intercept, the easiest way to write this is going to be writing this in factored form. So factored form is x minus the x-intercept, x minus the x-intercept times a. So if we substitute in there, the only thing we don't know yet is the value of a. So we're going to say x minus -1. So x minus -1, that's going to be x plus 1. And then x minus the other x-intercept, that's going to be x minus 3. Now, real quick, what I need you all to understand is we need to find the value of a. This is almost solved for, but we can use a little bit of intuition from last class to tell us what type of value a should be. So this is a downward facing parabola. So what that means is that a right here is going to have to be a negative number. So whenever we go and solve that, we can confirm it, or at least halfway confirm that it should be negative. We won't be able to say the exact value, but that is okay. So to find a, we've gotten this equation by using these two pieces of information. To finish getting this equation, we're going to use this piece of information, this y-intercept that says when x is 0 on this graph, y is 3. So we're going to substitute this into here. We're going to say, well, when y is 3, we don't know what a is, but x is going to be 0, and then we are going to solve for this. So that if we simplify this equation, we're going to get 3 equals a times 1 times -3. We're going to get -3a equals 3, and we're going to end up getting an a value of -1. Now, we're not trying to solve for a, although that is something we had to do. What we're setting out to do is write an equation for this parabola. So we'll say, okay, y equals -1 times x plus 1 times x minus 3. It's set up so now I can substitute in an x value and then get a y value. Set up so I can get an x value and then get a y value. So we're going to look at another example, but that's the baseline for what we're doing. So whenever I ask you to write an equation, it doesn't matter if it's in factored form or if it's in standard form. Both of those things, do the same thing. If you could FOIL this out to get it to standard form if you wanted. If not, that is okay. So this next one we're looking at, we've got let's see, the information we're given here. We've got a y-intercept of 8. Now, you'll notice here we've only got one x-intercept. Only one x-intercept, and that occurs at 2. Now, remember, we talked about last class, if you have a repeated root, if you only have one answer, it's going to come down and just touch at that 2 right there. So this x-intercept at 2 is occurring twice. So again, I'm going to use the factored form because we've got the x-intercepts here. So I'm going to say y equals a. So now the x-intercept here, we're going to say x minus 2 times x minus 2, or you could represent that if you want to not write out as much stuff, you could just say x minus 2 squared. And so again, we're in a similar situation to a here, where now all that we've got to do is say, okay, well, we know the value of a is going to be positive. This is an upward facing parabola. What we've got to do is say, okay, well, this y-intercept means that when x is 0, y is 8. So we're going to say 8 equals a times 0 minus 2 squared, and then we'll just go ahead and solve that. Well, a is negative 2 squared equals 8. Negative 2 squared is going to give me 4 times a equals 8, which means that a is going to equal 2. So when we write this equation, again, when we write this function, we're going to say y equals 2 times x minus 2 squared. That should be set up such that you can now substitute in an x value and you can get a y value out of it. Or if you have a y value, you can substitute it in and figure out what x value works for. So that is the first type of problem that we're going to look at today. Just using those features to write an equation. So let's look at a couple more different types of problems, because those aren't the only things that you could be given about a parabola. There's a couple of different scenarios that can happen here. So on this particular problem here, we're given this x-intercept here at negative 2. Let me say x-intercept. We're given a y-intercept of 16. And then we're also given that we have an axis of symmetry at 1. Now, the thing is, on the other two problems that we looked at, you needed, to write it in factored form, you need both x-intercepts. So we can see that this thing crosses the x-axis. Again, this is not drawn to scale. So what you all need to remember, if you've got the axis of symmetry right here, at x equals 1. The distance between the axis of symmetry to this x-intercept is going to be the same distance as the axis of symmetry to this x-intercept. So with that, so from 1 to negative 2, we go 1, 2, 3. There's a distance of 3 to the left. If I go 3 to the right from 1, 2, 3, 4, then we can use that feature of a parabola to say, okay, well, now we've got that other x-intercept. So the other x-intercept is now going to occur at 4, and we can proceed as normal. We can proceed as normal here. So let's see, we've got y equals a times x, let's see, minus negative 2, so that's going to be plus 2, and then we've got x minus 4, and now we need to solve for a. Again, the value of a here is going to be negative because this thing is facing downward. All of this stuff ties in to one another. So we're going to say, all right, well, we know this y-intercept here is the coordinate 0, 16. So we're going to say when y is 16, x is 0, and then we're going to solve for this. So let's see, that's going to be 2 times negative 4. So negative 8a equals 16. And we're going to divide both sides by negative 8 to get the value of negative 2. And again, we do need to write out that actual equation here. So we'll get negative 2 times x plus 2 times x minus 4. And this equation right here, this function represents that parabola. So we're going to look at, I think, what, we're going to call it 2 more examples, and we're going to call it a day for today, especially coming off of that quiz. I do not want to do more than one section today. So another way that we can do this, you're not always given the same information about a parabola. Maybe you have a point on it. Maybe you have a vertex. Maybe you have the x-intercepts. There's different ways that it can look. So in this example, we're going to try and find the equation of a quadratic whose graph cuts, this is just another way to say intercepts, the x-axis at 4 and negative 3. So that right there, I'm going to write down what we're given here. So for the x-intercept, we're given that they're 4 and negative 3. And here, we're given that it passes through. So that just says when x is 2, y is going to be negative 20. Now, here's the thing. If we don't specify what form we want it in, you can write whatever form you want. But this one wants the final answer there, and y equals ax squared plus bx plus c. So we can use factored form, but we want the final answer in standard form. So let's see, if we're writing this thing, we're going to say a, we don't know what a is yet. We're going to say x plus 4, not plus 4, excuse me, minus 4 times x plus 3. And let's see here. So now we're going to use this coordinate right here. When x is 2, so we're going to say a times 2 minus 4 times 2 plus 3. When x is 2, y is going to have a value of negative 20. That is a point that we know here. So we'll say 2 minus 4, well, that's negative 2. 2 plus 3, that's going to be 5 times a, and this is still equal to negative 20. So negative 10 times a equals negative 20, which means that a is going to have a value of 2. This is going to be a parabola that opens upward. So now when we write our equation in factored form, x minus 4 times x plus 3, we've got this equation right here, this function. This represents that parabola. We want it in standard form though. So we're going to do the reverse of factoring here. We're going to distribute. So the biggest thing that people mistake whenever they got a out here, they try to multiply 2 to every single thing. But you need to think about, like, if you had 2 times 3 times 4, you simplify this by doing the 2 times the 3 first. And you don't do 2 times the 3 times you don't multiply 2 times 3 and 4, because that's going to be a different problem. So we're going to multiply 2 times x minus 4 first. That's 2x minus 8 times x plus 3. And then now we're going to distribute here. Or some people call it FOIL. I prefer the word distribute. It's a little bit more versatile. Plus 6x minus 8x minus 24. Y equals 2x squared. Let's see. Minus 2x minus 24. And standard form is good for certain things. It's easier to find the vertex out of standard form. We can tell what the y-intercept is now. It's that c value right there, amongst other things. And so they're both useful for different parts of the parabola. So for the last example for today, we want to find an equation of a quadratic function that passes through these points right here. So none of these points are intercepts, but we are given 3 pieces of information here. We're given 3 pieces of information. So we know that when x is -2, that y is that. We know the same thing for 1 and for -4. We know the same thing for 3 and for 10. So what we've got to do, what we've got to understand is we're probably not going to be able to use factored form here because we don't know any of the x-intercepts. So what we're going to do is we're going to use standard form plus bx plus c. And what we're going to do is we're going to write an equation. So we're going to say when y is 5, when x is -2, so -2 squared plus b times -2 plus c. When y is -4, we're going to say, well, that's when x is 1, so 1 squared plus b times 1 plus c. And then the same thing for 3, 10. We're going to say, well, when y is 10, x is 3 plus b times 3 plus c. And then we're going to simplify these equations. We're going to get a system of simultaneous equations here. So we've got 5 equals 4a minus 2b plus c. We're going to get -4 equals a plus b plus c. And we're going to get 10 equals 9a plus 3b plus c. Now, remember, so we can solve 2x2 systems fairly quickly. But if we've got a 3x3 system, we'll use technology to solve that. The amount of time to solve that by hand is a little bit larger than Mr. Price wants us to spend time on. So to solve a system of simultaneous equations, if you go to apps there and you go to polynomials, simultaneous equations, that's what polysmalt means. So we're going to go to the simultaneous equation solver over here. We want to get answers for these equations. So what we're given, we've got 3 equations, not -3. Goodness, Mr. Price. We've got 3 unknowns, and we're going to substitute in what we know here. So Mr. Price, the way he wrote this, it's going to be a little bit in reverse. We're going to do 4, -2, and the c value is 1. We're just putting in those coefficients, and that is equal to 5. And then we're going to do the same thing here. We're going to say 1, 1, 1, and that's equal to -4 for that second equation there. And then we've got 9, 3, and 1, and we're going to set that equal to 10, and then we're going to just solve that. So x1, x2, x3, those are the values of a, b, and c here. So our the equation that's going to end up working here is going to be y equals 2x squared minus 1x minus 5. And that's the equation. If you graph that sucker, that's going to pass through all 3 of these points. And so that is where I want to stop for today. We covered a lot of different features of parabolas. So if you all have any questions on this, please let me know, and we can definitely look at this together. But otherwise, you all have a good day and have a good weekend if I don't see you. Bye.